well, what am I given in one triangle versus the other? And then does it match? Like just because you got in this case, a side, an angle, and a side, and the one on the left, is that actually what you have on the right?
No, it's not side angle side.
What do you have on the right then? It looked really similar to me. You got a side, an angle, and a side. Now it's flipped, it's reoriented, but so think of it as a path. Like side, side, angle, side. It's a path.
Mhm.
You have a path like that on the right?
Yeah, but it's flipped.
That's okay. These are congruent. They're not going to be in the same orientation.
So
All right. So this is, I can see there's going to be a problem here. What would really have to happen for you to like truly believe this is you'd have to have this cut out. You'd have to have this cut out, and then you'd actually have to like flip one over, and then you would see it. Flip and flip, you might see it. Um,
so it is a side angle side?
yeah, but I can hear the hesitation in your voice, and I understand. Did you guys do any visual manipulatives in class?
No, just the way that you said it made it sound like you were like pointing in the direction like, hey, this is not actually side angle side. Because that was my first thought was that it was a
Yeah,
side angle side, but
it is side angle side. But it won't necessarily be in the same like orientation. They can rotate, even flip. All right. So I won't say anything for the next one. I don't want to, I'm not trying to throw you off. Take a look at the next one and tell me what you see of those four.
um I'd say so I have a side, two angles, another side. So but it's two angles, not one angle. It's not side, side, it's not a side, side, another side. It's not side angle side. Angle side angle?
So this, when you say angle, side angle, the side has to be between the two angles. Is this sort of
Oh.
this top? Yeah, we don't maybe, but we don't see that. Which side is congruent though? Because it's shared.
Oh, it's like
Help.
flipped.
We had,
They're
we had
flipped
some
to each other.
letters here. You see how BD is congruent to itself?
Oh, yeah.
Okay, so now it's two angles and a side, but it's the side is not between the angles. How does that change your answer?
In two angles. So is it angle, angle, side?
Yes. And it's always a path. Angle, angle, side, and then the other way it's the same thing. It's an angle, angle, and a side. All right, let's take a look at another one here. I noticed in that last one I made a drawing kind of with them separated. I think that really could help to separate them. All right. Tell me what you see. Do you see the sides? Do you see angles? What do you see?
Well, I see one side, one angle per each of them.
Okay.
Or
So is there
flip.
anything else that's congruent that you can figure out by reasonableness, not by, hoping?
Well, they're connected. So there's like one line,
When it's shared or
they're shared.
overlapping, those are congruent.
Yeah.
So you have two sides and an angle, but is that angle between the two sides?
Um, 2000. Yes.
It
Yeah.
is.
Is it?
Oops. I don't know what that's weird. Oh, I know what happened. Okay. Sorry about that. Is this angle between the two sides?
Well,
Like it's over
uh,
here on the right, and then the
yeah. So
angle
it's not
between the
in
two.
between. It's not.
Yeah, so we can't just say angle side or side angle side because
Hmm.
the angle's not between there. Is there an angle side side theorem?
Angle side side. Oh yeah,
Yeah,
definitely.
no,
It's
this is
definitely.
the one you're not allowed to use. It's just these.
Oh, man, I'm not
SSS,
allowed to use ASS.
that is not allowed. In
But
my
that's
day,
like the best one.
that would get you to detention. It was like a big deal to pass that in math class. Um, so this is not
What if they
congruent.
just flipped the A to the back
Well, yeah,
side side angle?
yeah,
So
sure.
this,
Like but that's not how it works in life, right? You can't just be like, oh, what if, we could just do this. In geometry, it's very specific. It has to be very, very specific. So the answer is no. All right. Let's look at another one here.
hmm. Oh gee, oh God.
Tell me what you see on one of the triangles.
Oh. Well, I see there there are two angles. Wait, no, there's on each one there's one congruent angle and another congruent angle.
Okay. So we got two angles of it. We got an angle and an angle and an angle and an angle. Do you know anything else that's congruent about these triangles just by looking at it and reasonableness? Like,
The two arch angles, they're one line. Same thing with the other
so
arch
these are
angles.
called vertical angles.
Uh-huh.
These are congruent.
Yeah.
So is there an AAA congruence?
No, it's not an option here.
Nope. These are not congruent. Questions on that? Thoughts on that?
No, no questions.
Okay. All right. Number 5. Take a look at that.
They're all sides. So it's S
Okay.
S S
It's SSS. Yeah.
side, side, side.
Very good. 6 is probably the most difficult one. It
I think
goes
it's
back to
HL.
6 is not a right triangle.
Oh.
Nothing in there that shows you that that's a right triangle. Maybe because we haven't used it. Now, when you have parallel lines, it's probably easier to draw, and they're cut by a transversal. Okay, this angle is congruent to this angle. So that means this one up here is congruent to this down here.
Mm-hmm.
And then we have parallel lines cut by a transversal. This angle is congruent to this angle.
Mm-hmm.
And then what do you know about the side in between them? The
Those
shared.
are, I remember those symbols in class. I'm trying to remember what they meant. That means they're parallel, right? No, no.
Yeah, that's what I was showing here. These are parallel.
Oh,
These are parallel. That's how you get the angles. But what do you know about the shared side?
um, they're congruent
The
and they're
shared side is
connected.
congruent. So what do you have in each triangle? And sometimes you got to like, break them apart.
Each triangle they have an angle. Yeah, two angles. Congruent side. Uh, oh, angle side angle.
Angle, side angle. Good. All right. Any questions, thoughts on that?
Nope.
All right. So we're on to some proofs. Is this the only assignment for the week or just for tonight?
No, this is homework.
Okay.
The only
All right.
homework.
So the first thing is, what is the first statement in a proof?
Statements.
Yeah, what's the
Um,
first statement you always put in a proof?
you put down the givens.
Yes, and
The
it
angle BAC is congruent to EDC.
now it might be good to actually like show that in the picture. That's given. And then BC is congruent to EC. And that is also given. And then the last thing you can put in the proof is the proof statement.
Mm-hmm.
All right. So we need another statement. Now I'm going to tell you how they prove the triangle's congruent. To help, it's angle, angle, side. So right now you have an angle and a side, an angle and a side. You need another angle. Which angles are congruent?
Uh, B and E, right?
There's nothing that suggests that. Like maybe they look at, you can't use that. Like, what's your reason that they're congruent? Because it looked congruent? No, it has to be something else. But there is an angle that's congruent.
Um, C.
C is a single letter. You have to use 3 letters to refer to an angle when it's shared.
Um, Hold on.
It is, you're in the vicinity.
There
What
are,
is those angles?
I don't know. Well, there's only 3 letters, so I don't know. CE or CB.
Look, why is BAC this angle up here that I'm pointing at? Why is that BAC?
Because they're connected.
The middle letter is the vertex.
All right. Oh,
Okay, EDC, the middle letter is the vertex. So for the angle here, like I'm going to show in red. You give me this one in red right here. Use 3 letters for that one.
yeah, that's one congruent.
But C better be in the middle.
Oh, E is the congruent.
I feel like you have no idea what I'm talking about.
I recognize some of the word. I'm trying to freaking puzzle it together.
Let angle ACB is the one in red.
Mm-hmm.
ACB is the one in red. Why is that the one in red?
Oh,
Why?
because it's the proof.
No, no. C is the middle letter. That's the vertex. And then you
Oh,
start at one of the other ones and go to it. You're going A to C
oh,
to B, A to C to B.
oh, right, right.
Okay, so what angle is that congruent to on the right here on this other triangle?
DCE.
Yes. Now we got to know why. They meet at an X. What kind of angles meet at an X?
What?
What kind of angles meet at an X?
Gives me an X. The X-shaped one. I forget the name. Hold on, I
Yes.
have my folder.
Yeah, do you have anything to look up?
I have my
Reference.
folder, and that's my notes. I don't know. It's yeah,
All
it's
right,
that shape.
vertical angles. What are you going to do to remember that for next time?
Huh. I can write it down.
Okay. If you think that will help, that would be a good strategy. You have to figure out what works for you. All right, so that is it for that proof. Any questions on that before we move on to the next one, which is really, really similar?
No.
Okay. All right, let's take a look at the next one.
Hopefully this one's easier.
They're all about the same. I mean, they're not, it's the same recipe. You put the givens first. So the first given is that JK is congruent to LM, and it's good to actually diagram that. Now, whenever you have overlapping triangles, I recommend splitting them apart. JKM, and then the other one is LMK. Okay. You see how I split those triangles, these kind of ones on the right and left apart?
Yeah.
All right. The next given is that angle JKM, so the middle letter's the vertex, JKM, this one over here on the right, is congruent to LMK.
It's what? I'm sorry, you broke up for a second.
Yeah, I'm just writing the given. JKM is congruent to
JKM,
LMK.
so I write that down?
Yes, we're gonna write the second given down, and you've already got 50% of your proof done. Then you go to the proof statement.
Alright, so that's
We'll figure out what that is. Now, in this drawing, when I split them apart, it's harder to see, but do the two triangles share anything?
yeah, they share I mean N.
How about sides are the only things that they share typically. They typically share
Sides? Oh, they
sides.
share L to M and also J to K.
No, no, share means they're the same in both. Like if you have a brother and sister
Oh.
and you have a bedroom and they have a bedroom, you share a wall.
Mhm.
Do these triangles have anything shared? And they do. It's going to be a side. Which side is it that they're shared?
Um
Which letters are the same in both triangles?
N?
Letters. There's no N in this triangle on the left, no N in this triangle on the right.
Oh, uh, K.
That's one of them. What's the other one?
M.
Yes. So MK is congruent to KM. That's the reflexive property. Like if you look at yourself in the mirror, you look the same in the mirror on the other side. That's called a virtual image because it's not real. Okay. Now, what do you have in the three triangles? What, in terms of angles and sides, what do you have in this triangle on the left? Do you have a side? Do you have an angle? Do you have an angle or another angle, another side? What do you have on the left here or the right?
They have they have MK. That's the
Forget
thing.
about, we're just talking about sides and angles.
Okay, so they have a side angle side. Side
Yes.
angle side.
There's your reason. Theorem, postulate, whatever. All right. Good job. Good job. So we're gonna pick up on Wednesday. If you ever need some physics help, we could certainly do that. And I assume you'll have some more geometry for us to work on. But appreciate the effort, and I will see you on Wednesday.
Yeah, I see it too. See ya.
Okay, bye.
Bye.